let's look at some basic trigonometry that we can use in physics, starting with Pythagoras' rule of triangles. So let me draw a triangle, a right angle triangle. That's 3 units high there, 6 units high there. This is the right angle. This is some angle theta. Now Pythagoras' rule, as you remember, is the square on the hypotenuse is equal to the sum of the squares of the other two sides. That there is a square on this opposite side, that's 3 by 3. There's a square on the adjacent side, which is 6 by 6. Call that adjacent squared, we'll call that opposite squared. And there's a square on this hypotenuse here. Call that h squared. So Pythagoras' rule means that this h squared is equal to the sum of the squares on the other two sides. H squared equals a squared plus o squared. If we wanted h on its own, then we would square root the other side. So let's say h equals the square root of a squared plus o squared. Now let's stay with triangles. I'm going to redraw my triangle. There's a right angle, there's some angle theta. This is the opposite, this is the adjacent, and this is the hypotenuse. Now this adjacent side is it's adjacent, nearby, it's sort of cozy up to that little theta there, the angle. So I could write what that is in this form, that the hypotenuse times the cosine of theta equals the adjacent. And that opposite there is way over in the distance, way over there. It's sort of, look over there and you can see a sign in the distance of the opposite side. So I remember it by saying that, and the hypotenuse times the sine of the theta equals the opposite. And we can use those two to work out and rearrange them to find the angles and the opposites, the adjacent or the hypotenuse of any triangle in any problem. If we want to rearrange for h, we could say h equals a over cosine of theta, or h equals opposite over the sine of theta. We can rearrange the formulas in any way we wish to get what we need. In physics, we like to use a thing called standard form. It's a way of expressing numbers with indices when the numbers are very big or very small. So if I had the number 10 and raised it to the power 1, no surprise to you, that means times it by itself 1 times. So it's 10. If I had 10 to the power 2, that means times 10 twice. It's going to be 100. 10 to the power 3, you've guessed it, it's 1,000. But we also know that if I wrote it as 10 to the power minus 1, that would mean divide by 10. So I would get 0.1. If I had 10 to the power minus 2, then I would be dividing by 10 twice. So I'd be getting 0.01. And again, no surprise, if it was 10 to the minus 3, I'd be getting 0.001. But look at this, this is a tenth. Dividing by 10 is a tenth. So I could also express this as a tenth. I could express this as a hundredth. And I could express this as a thousandth. Why this is important is that when we come to writing units, there's a curious way that we deal with them. So if I was to say, what are the units of speed or velocity, then you would say meters per second, and you would probably write it like this, meters per second. But what does this really mean? It really means that it's meters divided by seconds, but that's a clumsy way of putting it. It's actually meters over seconds, but that looks messy too. what we're really saying is meters times by 1 over seconds. This 1 over second looks a bit like this, 1 over 10, which we've already said we can write like this. So 1 over second I could really write as s to the minus 1, seconds to the minus 1. That's what I've done here. But we don't need the times sign in, so I could write it as meters per second, like that. I might still say meters per second, but that's how we write it, meters times seconds raised to the power minus 1. If we were to say acceleration, we would say that's meters per second squared, but now we would write it as meters per second to the power minus 2, and so on. These are the units that you'll see in questions that we'll be using. Here are a couple more things that you need for A-level physics. You need a calculator, one like this, a scientific calculator that you can program in your formulas to solve problems. And you'll need this, which you'll get for free. It's all the formulas you need for the course and all the constants that we use in our calculations. Look at all these beautiful formulas, all given to you completely for free. And this is what you'll get in the actual exam. So I'll post this for you so you can download it. So at GCSE you have to remember them all. At A-level you get given them all. Because what it's really about is problem solving. It's not a memory game. It's not trying to remember the charge on the electron or remember the formula for even the simpler ones are in here too. It's not about remembering. It's about applying and solving problems.